At a somewhat larger scale, we have the effects of air masses. The United States is largely kind of in the mid-latitudes between the equator and the poles, and so we can potentially have an air mass move north into the US from more tropical areas, or south down from more polar areas. So far, trying to keep Canada from exporting winter weather has not been very successful. Again, we have maritime versus continental for either one. Maritime means it was sitting over the ocean, and so would be relatively humid. Continental means sitting over the land and relatively dry. So we can have our different air masses, and if one of those is sitting over us, we'll see a particular weather pattern. So for example, here in the southeastern US, a lot of our air, especially in summertime, was sitting over the Gulf of Mexico before it came here. Gulf of Mexico, water, so that's going to be maritime, so that air is pretty humid. And further south, it's going to be warm. So we get these big masses of hot, humid air moving into our area. And yep, if you've been around here in summertime, it's often hot and humid. What happens if we have polar and tropical air meeting up with each other? Now the picture here suggests polar and tropical kind of getting along well, but that is not true of our air masses. A polar air mass and a tropical air mass are going to be very different from each other, not mixed well, and the boundary, the front between them, is going to be a very sharp boundary. We're likely to see severe weather with that. And if you take a look at a map with the middle of the US, there's no mountains or anything blocking between the warm, humid tropical air that can come up from the Gulf of Mexico and cold polar air that can come down from Canada. And they tend to run into each other somewhere in the middle of the plains. Good old Tornado Alley. We often get quite severe weather, dramatic swings in the weather in this region, especially in the spring and fall as things are changing. For example, with the storm system that just came through southeast, before, out in the central part of the US, my brother in Kansas had a day with a high around 83, promptly followed by a night with a low in the 20s. Very drastic shift between the air coming up from the south and down from the north. How about a global scale? Well, the equator, it's warm there. Sun gets near overhead every day. It's cold at the poles. Sun never gets very high in the sky. So, we'd expect to see rising warm air near the equator, sinking cold air near the poles. And that would mean that we tend to see air blowing south from the pole toward the equator, north from the south pole towards the equator. So we get one big loop to the north, one to the south. Now, yeah, this is weather, troposphere, things are changing. This is a general average pattern, not something that would always be exactly the case. But, again, the Earth is spinning. So as that air is trying to go from the pole towards the equator, it gets bent off sideways, and so the actual average pattern is to have 3 loops to the north and 3 to the south rather than just 1. So again, near the equator, things are warm. We have the rising air. Okay, Air is going to be blowing towards that. But meanwhile, the Earth is spinning under it. And so that air gets bent from the east towards the west, as well as towards the equator. And so we get a fairly standard pattern of winds, the trade winds, in the more tropical parts of the globe. Moving up to the mid-latitudes, like where we are here, we've got sinking air, roughly 30 degrees north or south. And so then our winds will be blowing away from there towards yet another zone of rising air at about 60 degrees north for us, south for those in the mid-southern latitudes. And then once again, yep, it is cold air sinking at the poles, so we get another loop there. So our winds will tend to be coming from the west and also away from the equator towards the pole in our mid-latitudes, and then once again from the east and towards the equator in the polar regions. Okay, but what about the boundary zones? Say, right near the equator, air's mostly rising. So yeah, you get some light breezes here and there, but not a steady wind pattern like the trade winds. If you happen to be on a sailing ship, air going that way does you no good. Well, maybe if you've got pixie dust and going to Neverland, but apart from that, doesn't help. So this area known as the doldrums. You could easily get stuck there because there's not a lot of wind, no consistent pattern of wind there. Similarly, when we get around 30 degrees north or south, air is largely sinking rather than going sideways. Once again, that does not help your sailing ship. So we've got this zone of typically relatively weak, irregular winds, and a ship could get stuck there, and those are known as the horse latitudes. Why is not entirely certain. One suggestion is if you are sailing from Europe to your colony in the New World, and you're bringing a supply of useful farm and work animals, and then your ship gets stuck, you start to run low on hay. And before too long, you may be tossing some horses overboard. Maybe that's the origin. It's not entirely certain, but it gives you the idea of winds are not real great in those zones. So again, focusing a little bit more at the equator, warm, humid air is rising, less dense. We tend to get rain and clouds from that rising, warm, moist air. And then the winds on either side are going to be blowing towards the equator. But thanks to the Coriolis effect, they also are blowing from the east towards the west. Rain, this air is now pretty dry. As it sinks down, it's going to be warmed, so very clear, dry air. And so these areas, we have some deserts associated with the sinking air zones. High pressure, again, not very much wind at these transition zones 30 degrees north or south. Then when we move out to 60 degrees, once again we have a low, rising air, tends to be cloudy, probably more snow than rain, and our winds in between the 30 and 60 are coming out of the west and away from the equator. So around here, our standard wind direction is out of the southwest. Southern South America, Chile, Argentina. Here we've got winds out of the northwest. Trade winds north of the equator, it's the northeast trades coming out of the northeast, southeast trades on the south side, and then once more northeast or southeast winds in the polar regions. Again, cold sinking air at the poles. Now, these vary, for example, with the seasons. They'll shift north and south somewhat. Air is dynamic, it moves around. So this is not 24/7, 365 days a year. This is an average general pattern of winds. I mean, you've probably noticed sometimes winds blow from different directions. But usually the air around here, the winds are coming out of the southwest. That's our usual direction. A very important pattern of winds somewhat higher up in the air is the jet stream. Again, we've got our zone of tropical air, relatively warm, rises. Rising, we have less pressure, but that's going somewhere. Way up there is going to be tending to experience higher pressure from the rising air. So we need to think about where we're talking about, up there versus down here, for our pressure patterns. And so jet stream, again we have that relatively warm air near the equator. There will then be a distinct boundary associated with that sinking air between the warm equatorial air and the colder kind of mid-temperature air in mid-latitudes. And then again from our mid-latitude air to the polar air. And so along those boundaries, with the different major masses, not the little air masses that we tend to get above, well, big compared to us, but not as global scale, we get the jet stream along the boundaries between these. So this is a strong wind up around the top of the troposphere. As we saw with ocean currents, what's around a wind? More air. So it's very easy for this to get bends and maybe even split into more than one belt of wind and join up and stuff like that. It's not a constantly exactly the same condition. These winds are quite fast. If these were happening down the ground, they'd be a big problem, but way up in the air, well, it's just air around. Not going to run into anything by being blown there. It is very important for flying plane. If you are going in the same direction as the jet stream, hey, you got a nice boost. You can use less fuel and get there faster. If you're wanting to fly the other direction, rather than coming with the wind, you do not want to try to fly against that. You're going to find another route that doesn't have you trying to fly against the jet stream. The jet stream is well up there, but is very important for our weather down here because it helps to steer movement of fronts, air masses, highs and lows, things like that. So, for example, a bend in the jet stream, if in the wintertime the jet stream bends down rather further south than usual, that means that the polar air on the north side of that is present rather further south than usual. And we get extra cold Canadian air above us if that bend in the jet stream gets to where we are. Conversely, in the summertime, if we have a bend in the jet stream going the other way, we'd get somewhat more warm air coming up, or if the jet stream bends down south in the summer, which it does not usually do, but possibly could, we could get cooler air. So jet stream flow, very important in helping steer weather phenomena down here.